Hello students, the continuation of thermodynamics. In this session, we are going to learn about heat engine, the working principle of heat engine and the working efficiency of heat engine, first law of thermodynamics and how the limitations of thermodynamics which are all there, everything we will see. Yes students, heat engine. Actually, this heat engine helps to convert heat energy into the mechanical energy in a cyclic process. The process is a cyclic one, right? What is the principle of this heat engine? See, a system whose various parts are at different temperatures, always it tends to attain the state of thermal equilibrium. That is, this tendency which helps to be utilized to deliver actually some work to surroundings via some suitable arrangements we kept. See the diagram. So heat engine actually it has some essential parts. The essential parts are, the first one is source and sink, then the working substance. So this three is very important for the working nature for the heat engine. So what is the purpose and what are all we are using as a source? So actually source, it is a heat reservoir of that high temperature and that heat is absorbed. So the heat is absorbed through that. The temperature maybe we have taken as a T1 that can be absorbed in an infinite thermal capacity it will have. And next one is sink. See the sink, it is also a heat reservoir at low temperature. It is getting rejected. The temperature maybe T2 we have taken. The heat can be rejected through that. This also we have a plenty of infinite source of heat. Okay. The next one is working substance. This working substance actually we can take any material like solid, liquid or gaseous or any material we can take. But it has to be performed the mechanical work when the heat is supplied to the heat engine. Okay. So for example, if we have taken some mixture of fuel vapor or maybe like an air also which is used in a diesel engine or in the steam engine, right, which are using, no, that is so working substance as we said, right. See the diagram children, the working nature you must know about. The source as we said, heat reservoir, some source we have taken, okay. Now it is a cyclic process we said, so it is helpful to convert the heat energy into the mechanical energy in the cyclic process, right. Now the cyclic process of operation which is done in the working substance are getting absorbed in the definite manner of the heat. So it is taking the definite manner of amount of heat which is from the source at what temperature we said? It is at the high temperature. From the source it is taking from the high temperature and it converts the parts of the heat energy into the mechanical energy. So that time what is the meaning of it? Some work has to be done from that, right? So work is done for the particular heat energy. Then remaining heat, that Q2 we have. So now see that through the source the Q1 is absorbed and remaining source will be there. See, remaining heat will be there, that is we have considered as the Q2. So the Q2 which is to the sink at lower temperature T2. So the work done W in a cycle which is transferred to the environment by some arrangement. For example, the working substance may be cylinder with a movable piston means, and that is transferring the mechanical energy to the wheels of the vehicles, right? So in this way it is getting working and it is converting the heat energy into the mechanical energy in the same cyclic process it is doing. Okay. So how the efficiency of the heat engine will be there, the continuation of the heat engine process. Actually the efficiency which is the ratio of the net work done by the engine in one cycle to the amount of heat which is absorbed by the working substance from the source. Actually at that time we can say that the heat which is given by the heat engine, that means we are saying that as the working substance returns to its initial state after completing one cycle, there is no change in the internal energy. So that we can take it from the first law of thermodynamics, the net heat absorbed by the cycle, which is equal to work done. So that the net heat absorbed by the cycle, which is Q1 minus Q2. So Q1 minus Q2, which is equal to W. So this is from the first law of thermodynamics. We have taken from the efficiency of the heat engine Q1 minus Q2, which is equal to the work done. Now the efficiency of the heat engine, which is equal to eta, represented by eta, which is equal to work done by the engine of output, whole divided by the heat which is absorbed from the source, which is the input. So that W by Q1, which is equal to W, the work done, which is equal to what we have taken, Q1 minus Q2 whole divided by Q1. So we can write this as eta, which is equal to 1 minus Q2 by Q1. Okay, and we can say that the efficiency of the heat engine is always less than unity. See, the efficiency is always less than unity. So you know that is why, because of, we can say that is the, when Q2 which is equal to 0, the Q2 value which we have taken, that is equal to 0, then the eta value will definitely come to 1, or it will be like, we can say that is the 100% efficiency we will get whenever that Q2 which is 0, right? But any working substance working in a cycle that cannot be convert all the heat which is extended from the source into work. It will not be possible for that Q2 which is equal to 0 actually. So it has to reject some amount of heat to the sink, as we have already seen before that explanation part, that in the working principle, right? In that way, we can say that the efficiency of the heat engine is always less than unity. Yeah, types of heat engine. Actually, we have external combustion engine and the internal combustion engine. So actually, the external combustion engine, the heat which is needed for the working substance is produced by a burning of the fuel outside the cylinder and the piston arrangement of the engine. And we can say that internal combustion engine, which is inside that we can say that the heat which is needed for the engine, which is produced by burning of the fuel, which is inside and the main cylinder. Okay, the petrol and the diesel engines, which are is an internal combustion engine actually. And the limitations of the first law of thermodynamics. See, it does not indicate the direction of transfer of heat. The transfer of heat direction, it is not indicating. So that it is tough to using for another of the engine materials, right? Then does not tell about the conditions which we can say that suppose it is under the heat that can be converted into the mechanical energy. And also it does not indicate the extent to which heat which can be converted into the mechanical work continuously. So these are all some limitations for using the first law of thermodynamics. Yes students, so far we have learnt about the heat engine. Hope you people understood. Thank you students.